The interesting thing about Albert Einstein, he died in 1955, and what happened, they did an autopsy, okay, and the pathologist, okay, kept the brain. Without permission, without informing the relatives, the pathologist kept the brain, because he says, I need to know what is in this brain, what makes Albert Einstein different from me, what is the genius in Albert Einstein? I want to find out, okay? He didn't do much about it. He kept it in his garage for a long, long time, okay? And if you're interested to know what happened, you can actually read a book, and there's a movie called Driving Mr. Albert, about chronicling the life of the journalist who went around the whole country in the United States, looking for Albert Einstein's brain, finding it in the garage of the pathologist, okay? So what did they do? They sliced up the brain, gave it to a lot of people, and they found out that his brain, my brain, your brain, looks exactly the same. Okay, so we have a problem here. Okay, what made it different? So then, after some time, when the technology was there, we could look at the molecules, we could look at what is the content in the slides, and they found out that, okay, you have neurons, and those are the cells inside your brain. In between the neurons are embedded in something called glia, all right? And Albert Einstein, sorry, not Albert Einstein, sorry. Okay, what he had in Einstein's brain at that time, there was a lot of glial tissue. And that was the difference. And the glial tissue is very important for the ability to send information very quickly, all right, for the neurons that are there. Now, so not only that, they found that there are two areas that he had more cells than everyone else. One is something the anatomists call area 9 in front here, in the frontal area. The frontal area is related to learning and memory, executive functions, okay? And that area had more cells. When you have more cells, you can send information faster, you can understand things faster, all right? And you can do things basically faster than everyone else. It's like if you want to add 3,232 plus 100,000, you might take some time, do it on your computer, it's faster, okay? The networks are faster. You can do it, but the computer does it faster. Same thing here. And that linked also to area 39, by the sides here, and that is the area that is related to learning, to hearing, to vision, to areas related to smell, to touch, to emotion. So a lot of things here are linked, and they found that this is very clear that this is more developed in his brain, okay? Now, what it means is, at his age, okay, his brain was well developed, and it continued to develop, all right, in a concept that I will talk to you just after this. It's known as neuroplasticity, okay? We'll talk to you about what it means then, but it means that although he's a genius like that, all right, and you know the chap down there, Usain Bolt, that is physical athlete, well, Einstein, and as you grow older, you can still remain an athlete of the mind. But there are ways that you can do that, otherwise you end up being senile, all right? So you can teach an old brain new tricks, but we need to look at the levels of change. Now, I'm not sure if you can see this, but you see that diagram there, the GIF there? Okay, the number of cells are in black dots. Basically, the number of cells are not changing. What you see there, the dendrites, the connections between cells, they're known as dendrites, they are increasing. Now, the more connections you have between the cells, the faster you send information, the faster you can process the information, all right? Now, you can do that to your brain. Every time you get stimulated, every time you stimulate your brain, you increase the number of dendrites. Just now when you were out there, compared to you now, within the few seconds that you're here, thinking, processing things, all right, your dendrites have increased. And that has been proven, okay, scientifically. All right, so this is a concept known as neuroplasticity. It's like plasticine, all right? When you mold plasticine, you can mold it any way you like. Your brain, that way, is said to be plastic. You can mold it any way you like based on how much information you give or do not give to your brain. All right, so if you sit down doing nothing, you're not stimulating anything. The minute you stimulate your brain, you get dendritic growth. You get dendritic growth, you get better ability to process information. Okay, now this graph shows ability with age. Everybody thinks that there will be less ability when you grow old in terms of learning, okay? And that essentially is not quite true, okay? Because yes, the plasticity increases and the peak amount of brain matter is around 20 to 30 years old, so you know, you're at your peak right now, okay? Numeric ability is around 40 and 50, so next time you have any problem you can't solve and you get a poor mark, just tell your lecturers, yeah? Peak ability comes after we graduate, not now. Okay. And inductive reasoning, around 50, 60, old people like us, we talk a lot because peak verbal ability comes later on. Now, it's supposed to go down. And then you get senile and eventually you die. Not quite true, because you can do that. You see that? You can maintain. Okay, you can maintain your brain. You might grow older, right? I tell people, yes, I'm really getting old right now, but inside, I'm 29 years old. All right? Why am I 29? I don't know. I always pick that number, you know, like 29 inside. Why? Because your brain is active. When your brain is active, you grow dendrites. When you grow dendrites, you send information. Your brain remains young. Okay? So if you can't keep your body young, at least your brain is. All right. So that is neuroplasticity. Okay? So neuroplasticity is one concept there. That's how we mean by changing your mind. You change your brain, you change your mind. And this, okay, is an awesome, awesome ability. This is a gift that has been given to you. Can you imagine that? What we call a gift from God. He's given you that power to change your mind, changing your brain. What else can you change? You can't change and say, I want 3 fingers instead of 5, okay? You can't change your looks unless you can get Botox, but that's not a gift from God, okay? So you can actually change your mind. And that itself is a gift that sometimes we forget that has been given to us, you know? Okay, neuroplasticity. The next one is called neurogenesis. Now that picture there comes from a photomicrograph of neurons in an area called the hippocampus. Now, they say that if you're born with X number of neurons, how many neurons do you think you have in your brain? 1 million? 1 billion? 2.6 billion? 3 trillion? As many stars as there are in the universe. That's the number of neurons you have in your brain. You count that, you'll get it right. Okay? Now, those neurons, they say, cannot regenerate. Now, you lose your finger, you cannot get a new one. You lose your head, you can't get a new one for sure. You lose maybe your liver, that can regenerate. Okay? Your brain cells do not regenerate except in 2 places. All right? One is in smell area, olfactory area. The second one is an area called the hippocampus. All right, now where exactly is this hippocampus? And neuro means the nerve, genesis means to grow. So neurogenesis in the adult occurs in these cells. This is a photomicrograph, but if you look at the diagram, it's right behind your eyes. Okay, so you really got to protect this very well because you can actually injure your brain very easily, right behind your face. Okay? Right behind your nasal area, very, very small area called the hippocampus. This is the only area of importance for us, okay, that regenerates. And that area is responsible for learning. Okay, so that's the beauty of it. You can regenerate, meaning that learning is lifelong. All right? If you're an older person, do not ever tell me I'm old, I cannot learn. Never, never true. All right? You can learn at any age. All right? You just need to have the passion to do so. Okay, so that is neurogenesis. The third one, the third level of change is in neuropeptides. Peptides are proteins, small proteins, and found in the brain. They're neuropeptides. Okay, now these neuropeptides, the important one is what we call BDNF, brain-derived neurotropic factor. BDNF is important because with BDNF, you can get new neurons growing, neurogenesis. Okay, now how do I get BDNF? Is there a magic pill? If there is, you know, I can sell it to you and become a millionaire like right now. A billionaire. Okay, I can't do that. But you can make your own. How do you make your own BDNF? It's not in the food you eat. It is a major mediator of neuroplasticity. And you see how you make it? Okay, you see the diagram on the left and the one on your right, okay? We have groups of students, 20 of them. Some were sitting still, the other 20 were running, and after that they sat for an exam. Same paper, and you can see the one after a 20-minute walk, the lighting up of the brain. All right, because in this group, okay, after exercise allows you to generate BDNF, okay? Simple exercise. So after this, you can run to your cars that are outside that gate over there. I saw cars when I come in here, okay? So, and that's good for you. You see how much they care for you here. They want you to run to get BDNF. And that BDNF is important, okay, because it increases neurogenesis, because it allows for neuroplasticity, because by doing so, it allows you to get more information being processed faster than it normally does. So, okay, these are the three things, the three levels of change, and we can say mental stimulation, coming to listen to whatever it is you're listening to, okay, it promotes neuroplasticity. Physical exercise promotes neurogenesis. Okay, simple things. You don't have to buy these things at a mall somewhere. It's not going to cost you millions of dollars, but it is something you can do. All right, you know this picture very well, I'm sure. Before exams, after you get your results, same thing like that, okay? Why didn't I study? Okay, you can feel his pain, right? You can feel it. All right, why is that important? Because it tells you about stress. Why am I telling you about stress? Okay, you see the red area there? Just before that is the orange area. Too much stress. Too much stress, you can't think. All your hormones go haywire. Eventually, you get into the red area and there is burnout. All right, but stress is good for you. All right, what kind of stress? The kind of stress that gets you into the yellow zone. The green zone is not good. Too laid back. Do whatever you want. I don't care. Am I passing the exam? I don't care. You know, too laid back. Too little stress. You want to get yourself in that yellow zone. All right, and I don't know how you can do that because you come from different areas of study and different backgrounds. But if you get yourself in the yellow zone, that is so, so important. Why? Because stress, okay, from this diagram you can see, stress in that yellow zone increases neurogenesis. Simple. You get yourself slightly stressed, you get more neurogenesis. More neurogenesis, changing your brain to change your mind, okay? Too much, and you depress neurogenesis, you're going to get senile very, very soon, okay? So that's what you need. You need to learn what kind of behavior gets you into the yellow zone, what kind of behavior gets you into the red zone, okay? And you don't want that, but we have to remember stress is good, okay? All right. Now, before we go into the 5 things that are important for your brain, what are we looking at? Are we looking at the brain or are we looking at the mind? Now, if you are in the health sciences, you know that people are looking at health. All right? But nowadays, we say in the 21st century, we are no longer looking at health. We want to look at wellness. All right? And this is the illness-wellness continuum. On the red side, you have death. On the right side, you have a high level of wellness. Now, when you get sick, okay, the doctor learns about your signs, your symptoms, and whether you are getting more towards the red side or not, they'll give you some kind of medication. All right? What does the doctor do? All right? The doctor, by listening at your symptoms and signs and disabilities, is using, and this is what we still teach people in hospitals, this is a treatment paradigm. Meaning that I'm going to treat you until you get at the neutral point. That means you're not sick, but you're not really in the wellness zone either. Okay, but that makes me happy. I can send you home until hopefully you can come back again and see me and give you more medicine. All right, that is the treatment paradigm. Now, we don't want that anymore. We want people now in the 21st century to say that we want to be able to be treated beyond that. We want people to have an awareness. We want people to have education. We want people to have growth. Okay? We want a wellness paradigm. Okay? And that is why I'm here now. Because with my background in health, I'm not interested in looking at health anymore. I'm interested in looking at wellness. And why is it important for the brain? All right, because wellness and brain fitness go together. Why do they go together? Because if you learn the correct ways, you can improve on your reasoning, you can improve on your willpower, you can improve on planning and execution, because what we're going to teach you is how to use the frontal areas of your brain. Why are these three things important? Because they are the foundations of wisdom. Okay, these are the things that will allow you to think. These are the things that will bring you forward, all right, in terms of how you think, in terms of how you approach things. So, wellness and fitness has to begin in the brain. Okay. Now, this is a picture before I go on, taken at UTAR, Kampa 2008. We were here back then, God knows, it was like, what, 6, 7 years ago, a really long time. Okay. We came in an exhibition, we showed people about the brain. Next time I have an opportunity, I could bring our brain, mobile brain unit again. This is a picture of your own students. With our students, I'm sure they're now working together, working somewhere, successful somewhere else. But they became part of our facilitators and helped the community learn more about the brain. Okay, some more pictures here. So, what I'm going to say is that I really enjoyed coming back here, seeing this place, okay? And thank you very much to all concerned for allowing me to have that opportunity. And for today, what we're going to look at is at 3 levels of understanding. I like the number 3. Okay, the first one is we look at strategies. What kind of strategies can help you improve your mind, okay? We look at what are the 5 rules that govern how the brain thinks. Because if you know those rules, then you can actually improve your brain and therefore improve your mind, okay? And then we have to learn to work with our brain, not against it. Sometimes the things that we do work against the way the brain works. And if you work against the brain, you're not going to get anywhere very, very fast, okay? So we have to work with the brain, not against the brain and how it behaves, okay? So now we've finished that component, we need to look at how we can empower the mind. And to do that, we have 5 ways, 5 brain rules that we can look at, okay? You know this picture? Okay, I dread this picture very much. You know, lecturer talks like that. Students at the back, I don't know. That ones are doing a lot of things, are sleeping. I know from experience, my students know how to use their phones very well by looking at me and smiling and sending messages. You know, it's like your fingers know exactly where to go to send things, okay? I don't know, Facebook, Instagram, whatever, you do this really, really well, you know? And I have to congratulate you, very good. And we need your attention, actually. And why we need that attention, you look at this picture, yeah? There are 4 white balls on this side. Those are representative of neurons. Now, each neuron connects to another neuron, connects to another, and eventually you have this whole mess, okay? And this is how your brain works, and it's just 4. Remember I told you have trillions, as many as the stars in the sky. Can you imagine how many networks there are, how many pathways there are inside your brain, okay? Now, why are there so many connections? All right, there's so many connections simply because, okay, in your brain, it is a self-organizing network. It works on its own in many ways. Otherwise, walking from here to here, I have to think where my next foot is going. All right? On the other hand, you could have walked here, got a message from someone, looked at your iPhone, and still managed to sit down. Of course, I think last year 2 people died when looking at their messages and they fell off a cliff, right? So maybe they were not as good as you are, but certainly these connections are very, very important, all right? Because your brain learns on its own, it is a self-organizing network. All right, what are the implications for learning? The implications are that so many things are happening. All right, when you're sitting down here, okay, you're not just sitting down. You have to listen, you have to look interested, you have to keep your eyes open and look like you're paying attention. All right, and the person next to you is sending something, there's a message from your mom saying, where are you? When are you coming back? You're thinking, and if you're a parent, maybe you're thinking about what am I going to cook after this? I have to go to Tesco, isn't it down there? Yeah, I have to go to Tesco first. so many things are competing for your attention, all right, because of all these networks, and that is a major problem. So the first rule that the brain and you have to learn is how to focus that attention that you have, all right? And luckily for you, we have what we call the cocktail party effect. I think if you've been to a conference, all right, there are so many people talking, all right, and around you so much is happening, yet you can focus on one person. You can talk to that person, all right? And that is because you have focused on one information and shut out all the others, all right? Now, can that be done? That is something that you have to learn. Now, I want you, all right, to only read the words, read them to yourself in capital letters, only those that are in capital letters. Okay? What did the small little words say? Don't know. Don't know, don't care. Okay? Because Dr. Zalina said, read the ones in capital letters, so we follow what she says, all right? But the little ones also say that what is most surprising is that not only can you focus attention on one of the messages, but you are completely unaware of the other one, all right? And that is, you're already using your brain, right? You leave out something and you use something else, and you focus only on what you want to focus on. That may be good, that may be bad, okay? And we need to see this, and I hope that it works.
The monkey business illusion.
All right.
Count how many times the players wearing white pass the ball. The correct answer is 16 passes.
You get 16?
Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion.
Okay, so you get that? People say, I've seen that before. Some people miss the curtains. Some people miss that one of the players in black actually left the scene, all right? Meaning to say that where you focus your attention is so important. Meaning to say that if you are if you're doing something that you want people to have your attention, okay, you've got to focus on what you want them to know. And you can easily direct people to where you want them to go, or you can easily misdirect people if that's what you want to do. Now, attention spans, yeah? Now, data has shown us that the attention span of an average adolescent up to your age into university is only 12 seconds in the year 2000. Attention span, 12 seconds, not much, okay? Now, in 2012, it dropped to 8 seconds, okay? Now, look, goldfish have an attention span of 9 seconds. Meaning to say you're worse than a goldfish. All right? The attention span of the average human, less than a goldfish. Now, okay? Meaning to say that now I can understand when I tell my kids, go clean up, nobody listens to me. Okay? It's attention, focusing elsewhere, selective attention, plus no attention span. All right, why does that happen? It's technology. All right, because technology says, if I want an answer, I don't have to wait tomorrow to ask my lecturer, I Google it. Okay, I can get the answer now. And we are living in a generation where we want the answer now, and now, don't make me wait till tomorrow, I want that answer now. Okay, and you're easily distracted. That works because you're playing computer games all the time, maybe, that's fine, okay, but it's not easy if you want to give a lecture for 1 hour, right? So, how to keep people with short attention spans, what we need to do, therefore, is you need to learn to present things, okay, quickly and clearly, talk quickly within 9 seconds. All right? Otherwise, people don't listen to you. No, it's going to be difficult. But on the other hand, I mean, you're university students. What's going to happen to you next? Perhaps when you graduate, you want to look for a job. Okay? Meaning to say, you have to be familiar with what they call the 1-minute elevator speech. You familiar with that? You do management, you will. The 1-minute elevator speech is say that you are waiting for a lift, the elevator, then suddenly, Steve Jobs did, all right? Some big CEO of a company comes next to you, okay? Goes inside the lift. This is your opportunity because you're both going to the top floor. In 1 minute, you're going to reach there. He asks you, what do you do? And you tell him, oh, by the way, I was a student at UTAR and I studied this. The door opens, he's gone. Missed opportunity. You have to learn in 1 minute to say, what is it you do? Why do you do it well? What is it that you want from the company? That is the 1-minute elevator speech, okay? And one of the reasons why you have to learn to do that, one of the reasons why you have to give facts quickly, fast, and efficiently is because people's attention spans are very, very short, okay? All right, so rule number 1 is that you have to have an ability to allow people to focus, or you need to focus, and you need to do things really fast. Okay. Then we come to rule number 2, it's related to memory. All right, memory comes from a lot of things. What you see, what you hear, what you feel, okay, they all enter your brain. They go to a part of the brain known as the sensory area, okay? And in the sensory memory, it is known as very, very short-term memory. Okay, it goes in, it goes out within milliseconds, unless you do something. Okay, and what you need to do is to code it, okay, your brain needs to code it into short-term storage, all right, which is why your brains normally do this very well, which is why that you understand a lecture completely. Everything your lecturer tells you is so clear, all right, you get out that door, you forget everything. Okay, short-term, doesn't go anywhere. What you need to do, because you see your short-term has to go into working memory. From working memory, you get to retrieve it, and then the performance, perhaps answering an exam question. But your problem is, from short-term, it needs to go into long-term memory. You need to consolidate. You need to be able to put it into storage. Then you have another problem. How do I take it out of storage? Yeah, I studied so well for my exam. I know everything. I look at the paper, cannot answer. Okay? Because you have to learn how to take it out of long-term storage, put it into working memory, retrieve it, and then perform. Okay? How do you do that? All right? One of the things is that, you see, this is where you can lose information. Short-term, into short-term storage, you store it, but you can't put it into long-term. Or when you have stored everything into long-term, you cannot retrieve. All right? So now the lecture now is too short to mention on ways or mechanisms for doing this. All right, but we will say that what you need to remember something is an intense experience, and that experience will allow you to remember how to reorganize your brain. All right, now I want you to try to remember, please don't write this down, it's not an exam. If you fail, that's okay. All right, 18 words, see? Can you try to remember those words as best as you can? Don't write it down, yeah? Okay? All right. Do you think you can remember the words? All of it? If you're all of it, I want to see you after this. Okay? All right. You probably remembered cat, apple, ball. If you can see that, you probably remembered the first few. You probably remembered the last few, but you didn't remember the ones in between, most likely, okay? So, remembering the first few is known as the primacy effect. The first thing you see, you will remember, all right? The last few words, tape, arrow, flower, book, or something towards the end, those are the ones you remember when you think that, oh, she's going to not show it to me now, she's going to remove the words, so you try and look what are the ones at the bottom. Okay, that's the most recent one that you looked at. You see, in between, you don't remember anything. It's just like a lecture, right? You remember the lecturer saying, hello, good afternoon, thank you very much. And then at the end, in conclusion, thank you. Okay? You remember that very well. What happened in between, don't know. Okay? So, the lecturer's duty is to say, how do I make the in-between more exciting? I have to have an intense experience in between so that students remember something. Now, this is known as the von Restorff effect, named after the PhD student who discovered this phenomenon, meaning to say that you have to make sure that the information you give in between is something so memorable that people will remember it, maybe beyond the room, the door, maybe up to the car park, if I'm lucky. Okay, so those are the rules, yeah? That's the second rule. First is attention. Second one is memory. You have to play around with people's memory such a way that you give them information that they can remember, and they can remember this because it was fun to remember, because there was something that made you remember that information. All right. Now, rule number 3, it's known as consolidation. Now, you have so much information, all right? You had a lecture in the morning, a lecture in the afternoon, and then you had practicals, etc. How do you consolidate these things? How do you make it something that you can remember, all right? Because when I talked about neuroplasticity, this is short term. We talk about exercise, that is short term as well. So that information goes in your brain, okay? And what it does is it makes a brain map inside your brain. But that brain map doesn't stay there forever. What your brain needs to do is to consolidate, meaning to say this requires months, all right? And meaning to say that it will make brain maps that are smaller in size, that can be stored easily inside your brain. What do you need to do? Okay? Unfortunately, what I'm going to ask you to do, please don't do it now. All right? This is what you need to do. Okay? Not have a baby, sleep like a baby. Okay? Sleep like a baby. All right? There's a difference there. Sleep like a baby. Why sleep? All right? Why sleep? Because during sleep, okay, consolidation of information occurs there. A lot of things happen during sleep. You think that sleep is time for you to rest, but actually sleep is the busiest time for your body. Your hormones act, your immune system goes into play. A lot of other things happen. One of them is consolidation of all the information, so that when you wake up, you have that moment, you say, aha, now I know what I have to do. All right, the problem has been plaguing you for months. All right, you go to sleep, and then when you wake up, you may remember. Now, this may not be too clear to you, but all right, what I have here is a diagram that shows you the different stages of sleep. And I assume that you sleep, this one assumes you sleep from midnight to 8 a.m. I think that's rubbish, right? Nobody sleeps that long. Or maybe you sleep like really long. Okay. But in that time, okay, you have what we call non-REM sleep. I'll tell you what that is later. And you go to a stage 1, light sleep, stage 2, okay, a deeper sleep, and then you go right down to the bottom, that is stage 3, the deepest sleep you have. Now that's very restful sleep, okay? And during that time, a lot of repair goes on inside your body, a lot of hormones are released, okay? This is really rest and recuperate, okay? And then, all right, and when you do an EEG, you get what we call slow waves. That's why it's also known as slow wave sleep, all right? Then about 2 a.m., right, the sleep lightens. Okay, it goes from stage 3, stage 2, okay, and then it goes into something called REM sleep, rapid eye movement, REM, rapid eye movement. Now, if you are in rapid eye movement sleep, this is when you have dreams, okay, this is when the heart rate goes up, okay, blood pressure goes up, breathing increases, and it is as if you are awake, and sometimes they call it paradoxical sleep, rapid eye movement. Okay, now, if you are living in a hostel, or you have a flatmate, okay, you just watch them when they're asleep, rapid eye movement, you know. You can see that in babies very clearly, but watch it. As soon as that happens, wake them up, okay? See what happens. They're going to get very, very angry at you. All right, you know why? Because they're having this really nice dream, okay? You're going to get really mad. Okay, that's not the right place to wake people up unless they're your enemy, all right? Now, you get REM sleep, goes back down into deep sleep, all right? The deep sleep lasts for about another, 1 hour or so, goes back into REM, okay? Then the sleep becomes lighter and lighter, and you get more and more REM sleep, and eventually you wake up. All right, so this is the cycle, and that cycle is very important, okay? Now, why is that cycle important in terms of the brain, and why am I asking you to sleep? Or is that during deep sleep, this is where you consolidate memory. Two types of memory, okay? One is known as episodic, the other is spatial. What is episodic memory? Episodic memory relates to your experiences, relates to what has happened to you during the day. All right, spatial relates to you in terms of your surroundings, the environment around you. You consolidate that information. And REM sleep is important. It consolidates procedural and emotional memories. Emotional, you know. Procedural are things like driving a car. If you are good at it, sometimes you don't even know and say, oops, I've already arrived. Okay, this is automatic. Okay, these are procedural memories. So rule number 3 would require you to sleep. Okay, because sleep is important, it consolidates your memory. Okay, and that is how your brain works. That's number 3. All right, let's go to number 4. See that picture? I don't know if it's too clear. It's at the Singapore Zoo. On one side you have 2 orangutan, the other side you have 2 children. I don't know who is on which side, okay, but they're doing exactly the same thing, right? It's a form of socialization. Hey, can you do this? You know, that kind of thing. All right, it's a form of socialization. Why do you do that? You do that because you have in your brain something very unique known as mirror neurons. All right, it's very important. These mirror neurons are very important because they are the cognitive basis for social learning. They allow you to empathize with someone. They allow you to understand what someone else is doing because you mirror in your brain exactly what that person is doing. Okay? Now, this is a picture of a Professor Malkoff taken, you can see from his hairstyle, that must be in the 70s, right? All right, so 70s, early 80s. Now he found that if he did all these facial expressions continuously to young newborn babies, some as old as 48 hours after birth, that's what happens. They follow him. Okay, they mirror what he is doing. And that's exactly how you learn language, how you learn how to walk, how you learn how to imitate what other people are doing. Okay, your mirror neurons. Now, he did this a long time before we even knew there were things called mirror neurons. But in 2009, Rizzolatti et al. Found that there are such neurons in the brain. And it is because of these neurons that allow you, all right, to imitate other people, to allow you to socialize, okay? So when you look at the mirror neurons, the socialization aspect, the mirror neurons are very important. They allow you to see what other people are doing, okay? They allow you to be aware about the goals of other people, and it activates your neurons. All right? Secondly, it is also important for relationships because now I can look at someone, I look at their facial expression, I understand what's going on, I empathize. So mirror neurons allow us to look at people and to say, okay, yes, I want to know you more, or no, I don't. And again, if we take that interview analogy, how you behave in these first few seconds are very, very important. You walk in the door, what you wear, how you behave, how you talk. In that first few seconds, the interviewer will already have an impression on you that is very difficult for that person to lose, even after whatever you say after that, okay? Because the mirror neurons are working over time, all right? And it, of course, allows for understanding. You look at previous experiences, you look at your experience now, you correlate those two together so that you can behave in the way that is required of you. Above all, mirror neurons are important for socializing, for empathy, how you empathize with others. Now, is this important? Okay, we take a look at this. Okay, mirror neurons, and we look at this. This shows mirror activity on the vertical axis, horizontal axis in years. Just look at the blue line. The blue line is for normal adults, hopefully all of us here, okay? And what it shows is that you have a lot of mirror neurons at the age of 20, and it declines over the years. And that is okay, because at the age of 20, before that, this is the time you want to socialize. This is the time you want to learn. This is the time you want to know more about how to behave with people around you, okay? And as you grow older, other things take place. Now, look at the red one. The red one occurs in autism. You know autism, don't you? All right? We have a problem with autism. One of the reasons that people have autism, you look at the number of mirror neurons they have at the age of 20, almost nothing, 0. All right? But the number of mirror neurons increase as they grow older. Meaning to say, at a time when we require more mirror neurons, at a time when this socialization process is so important, okay, that is the time autistic people do not have the neurons. They cannot socialize, all right? But because they increase in neurons over time, you will see that in some autistic children, all right, they can be rehabilitated because they have had an increase in the number of mirror neurons, okay? So, we come to the fourth rule. All right, now I want you to look at those pictures there. What does it make you want to do? I told you to sleep. Now I'm telling you to yawn. Does it make you feel sleepy? If it does, makes you yawn, okay, your mirror neurons are at work. This is a practical example of mirror neurons at work. You don't know who he is. You don't care who he is. I took his picture off internet somewhere, okay? You don't care who he is, but yet you empathize and you yawn because he yawned. All right? Why did you do that? Because your mirror neurons are working. Okay? And if you didn't feel sleepy, your mirror neurons have a problem. I'll see you after this. Okay? So, rule number 4, socialization. All right? It's important. Your brain is a social structure. You need to socialize. You need to engage your mirror neurons. All right? The 5th is visualization, all right? Now you have tacit knowledge, knowledge that comes from your experience, from your understanding, from internal, from your spirituality, things you cannot quantify. You get explicit knowledge that comes in from what you learn from the books, from what you understand by reading, for example, from your lectures, and this comes in, a lot of it comes in visually, all right? And vision is very important. Now, 4 key properties. Right? Number 1, this process of looking at something and understanding it is effortless. You look, you understand. It's not that you have to look and think. Yeah? If you do that to everything, you'll never progress. But it is effortless. Now, that is good and that is bad, because I want you now to look at this and tell me, is that a left or a right hand? Left or right hand? Left. Sure?
Yes.
Okay, why is it the left hand? Yeah, you kind of turn it around in your brain, put your hand there maybe, and you know it is left because you know that is a hand. Okay, you know a keyboard. Now, show this to a society that has never seen a keyboard, and you can't tell you, they can't tell you, is it a left hand or a right hand? Because they have never seen the keyboard, all right? Meaning to say that the image is only as good as the clue that you give to it. Meaning to say, if you're giving people information, you have to work within the cultural context of that community, all right? When you design information charts, when you're going into a community giving an exhibition, for example, when you prepare learning materials, make sure you know who you're working with, okay? Because your brain is going to make a decision effortlessly. Either you understand or you don't know. And you will not know this if you don't know what is a keyboard. All right, now, this one. Can you draw this on a piece of paper? It says, the star is above the square, and the triangle is next to the square. Can you just draw it? Because you need to be able to refer back to your drawing. Yeah? There is a star. That star is above the square. The star is above the square. The triangle is next to the square. Okay? Alright, if you've drawn this, did you get any of these pictures? Any of these diagrams? Star is above the square, triangle next to the square. Did some of you get something else different? But still managed to answer still fulfill the conditions? You probably did, right? Because there are more than 60,000 combinations, okay, that you can do. So you may not necessarily fulfill one of these and still be right. So I'm right, and so are you. Okay? You still say the star is above the square, the triangle is next to the square. Okay? Now, what is this? The word here is determinism. Okay? Star is above the square, triangle is next to the square, meaning to say that the sentence I gave you wasn't very clear. But your brain, okay, took that unclear sentence and made it into a visual representation. That visual representation may or may not have been what I wanted. Okay, assuming that those four were what I wanted. So what does this mean? This means that determinism is important. Your brain determines what it reads, but you cannot be vague. If you are vague, the brain that is listening to you will misunderstand. Okay, so that is one other component of visualization. You cannot be vague, you must be exact, because the brain will make its own conclusions. And the conclusions may not be right if what I wanted to say was not right. Okay. This one. A, B, C, D. B, C, or D fits with A. Is it B? Is it B? Is it C? How many people say C? Okay, how many people say B? Brave people. How many people say D? D? What do you need to do? You have to move it in your brain, right? And sometimes you have problems doing that. Basically, they're all the same, aren't they? Yes, they can fit in if you do some mental acrobatics and shift it around in your brain. Some of us can do it fast, some of us do it a bit slow, but it involves movement. It involves the motor system. You're not moving, but your brain is doing the moving itself inside the brain, okay? So, meaning to say that perception is related to motion, meaning to say that if you want to do something, you must make sure it is animated. Animation will be something that's really good for you, okay? Because then your brain understands. Now, for example, take this. I tell you the arrow is moving in this direction. So the box that has the black and white squares, which way is that box moving? Okay, you see the arrow? The handle is moving in one direction. Is the box, the black and white box, is it moving in the direction of A or B? A? I never can get this right. B? There's no C. Okay. B. Okay. What do you have to do? It's difficult because I just show it to you like that and say which way is it moving. Alright? Your brain doesn't work that way. Your brain does not work that way. Besides animation, what you need to do is break it down. Decompose that problem. That's how the brain works. If you get a problem, decompose it. Basically, I should have shown you the first thing first. It moves in that direction. Now, the second part. Now, which way does that gear move? All right? Then which way does the third gear move? The fourth, and then you will get your answer easier. In the end, you get your answer, but you get your answer faster if you work with your brain, and your brain wants to have things decomposed into its components. Okay, so that is how things have to be done in order for people to understand, otherwise it gets more difficult. All right? Okay, now this one, I think some of you have seen this before, and some of you may not. Okay, the rectangle that I have on the right, on your right, okay? And look at these two things now. If I move that rectangle here, it merges. Meaning to say that rectangle is exactly the same color as that structure, the top part of that structure. Now, if I take that same rectangle and I move it down below, it also merges. Meaning to say the bottom of that image there, that structure, is exactly the same as this color. Conclusion, top and bottom are the same color. Am I right? I have to be right, right? I'm giving the lecture. Am I right? Okay, I'm telling you, but do you see that now that I tell you I'm right? You don't. You see that? You saw that. Congratulations. Difference? You saw that they're both the same? Okay. Mm-hmm. Okay. Oh, very interesting. You should scan him. Okay. All right. Now, you remove the center part. Then you see the same color. Will you not? Okay. Because what? Your brain thinks in terms of dimensions. And it says if it is this shape, therefore the top has to be this color, the bottom has to be this color. Your brain makes preconceptions. All right. Remove that, and you will see two colors. Remove the three-dimensionality again, and you see exactly one color. Okay? It's not a trick. In the exhibition that we actually have pictures, okay, showing people so that they can come and cover the center bit and see that it's the same. Now, despite telling you that it's the same, with the exception of our chap down there, we still see two colors. Meaning to say, the brain makes its own pre-interpretation of things. Sometimes you cannot change people's minds. They have preconceived ideas. There's nothing that you can do to change their minds, okay? Because of this preconceived ideas. So, rule number 5, okay, has these 4 components, all right? And what it says, therefore, is that we have 5 components, 5 brain rules. The 5th one is visualization, all right? So, okay, we've looked at the 5 rules, okay, that we can now rewire the brain. You can change your brain in order to change your mind. And I need to show you this because I'm a physiologist. And this is neuroscience's most famous patient. Every physiologist must give at least one lecture where they always show this patient. If not, they're not a good physiologist, so I have to show you. All right, this is Phineas Gage. Phineas Gage, okay, was a construction supervisor making railway tracks in the 18th century in America, okay? One day there was an explosion and the railway track, okay, part of the railway track got blown up, went in the sky and went through his head. Okay, now which way did it go? It went through the skull, came out through his cheek, right? They pulled it out, okay, that's the iron rod he's holding, and he still lived. Why did he still live? Because it went through the frontal lobe. Frontal lobe is only for learning, memory, expressions, emotions, okay? If it had gone through the back part here, then he would have died because it is the part in your neck here that is related to regulating your breathing and your heart rate. But it went to the front, okay? And it came out through his cheek, so he lived, okay? But there was some changes in Phineas Gage. What happened was, he was a very good supervisor. He was a very good father, a very good husband, and after this injury, okay, he lived, but he became a terrible husband. He was abusive. He was abusive to his workers, okay? And basically they say he was no longer Phineas Gage. And why is he important to us? Because his brain his condition provided us that first link, that there is a connection between the brain and the mind. You injure the brain, you injure the personality. And then, is that all? What happened to Phineas Gage was he gave up living in America, he went to South America, he worked as a stagecoach driver, a driver of a horse carriage, okay? And every day he did the same thing, again and again. He went through, he'd wake up in the morning, have my food, go to work, run the carriage, come back, go to sleep, wake up, and so on. His life became a routine. And he learned slowly, okay? He rebuilt his neurons, he rebuilt his brain, and he became more like himself when he came back to America. So what we learned from him is that you can optimize the brain-mind connection. You can increase your knowledge if you use that brain frequently, okay? You can actually improve the quality of your performances. You can actually improve decision-making. All right, so this is what we learned from Phineas Gage, and that is why everybody who teaches neurosciences wants to show you the neurosciences' most famous patient, because he was the first one, actually, that showed us physical evidence that there is a link between the brain and the mind. So yes, you can rewire your brain. Yes, you can change your brain to change your mind. Now, where do we go from here? All right? We know all that. Where do we go from here? We've looked at three components. We've looked at neuroplasticity. Okay, we can increase the number of dendrites by stimulation. We've looked at neurogenesis. You do exercise and you increase the neuropeptides, you can actually increase the number of neurons in the part of your brain related to memory. Okay? Then we looked at 3 levels of understanding. We said that there are certain strategies that we can do to improve our behavior, to improve our work with, and how we can improve the brain, and how we can work with the brain, not against it. And that's important, right? Working with, not against the brain. And then we came up with 5 brain rules about attention, memory. We need to sleep for consolidation. We need the mirror neurons for socialization, and we need to be able to visualize. Okay, and these are the basis of how the brain works. Okay, now, and when we looked at Phineas Gage, he was the first one to now show us the link between the brain and mind. So have we answered the question asked a long time back? What is the link between brain and mind? Maybe yes, maybe no. We still cannot make that link. Okay? So, I have a problem here. We say, what next? Where do we go from here? What are the problems that we face? 2 major ones, okay, that we'll be facing, and we are facing now in the 21st century. Problems that I feel are a major problem that will be facing us, and in fact are facing us now. Now, you look at the 2 pictures, the four MRI diagrams. The one on the left is men, and the one on the right is women. And it shows you gray matter and white matter. All right? Now, men have 6.5 times more gray matter related to intelligence. Okay, don't worry, okay? It's just they have 6.5 times more gray matter. Gray matter are your neurons itself, the cells itself. Okay? Now, so meaning to say, they can process information very well. Now, women, on the other hand, have 10 times more of the white matter. The matter, the stuff that's in between those neurons. Okay? What does that mean? It means women are better at integrating information. Meaning to say that when we did a cognitive test, whether you're male or female, eventually the answers will be the same. It's just that men and women take different ways to reach the same answer. Okay? Because when you do a performance measure of cognitive ability, it doesn't matter, male or female, you get the same answer, but you find the way you get to that answer is different. Now, this is a whole lecture on itself. We can look at the brain of males and females and tell you how similar or how different they are. For example, right, in the hippocampus, women have a better ability to memorize things. Is that good or is that bad? It may be good. All right, it's going to be bad for you guys because you take out your girlfriend for dinner and she remembers everything. Next year, she says it's the anniversary. Do you remember that? No. There are differences that we have to take into account, all right? And that they have to work together to come to a conclusion. But this is a problem. Why am I saying this is a problem? Because you look here, all right? These are children, and the one in red are males, and the blue are females, all right? Now, in terms of, at a young age, in terms of educational disability, more male children. Learning disability, males. Emotional disturbances, speech impairment, mental retardation, you see this more often in male children rather than females. Okay, why? One of the reasons has to do with the picture I showed you before this, the number of neurons. Okay, now, male, let's say a male fetus growing inside the mother's womb, okay, uterus, okay, and is subject to some form of toxin, okay? Now, they have a lot more neurons to lose than if it was a female fetus. So the male fetus will lose more neurons than the female, and this becomes significant nowadays. When you have the Zika virus, for example, that attacks fetuses. When you have toxins in the air that attack babies, okay, that are unborn, for example, it's going to affect male children more than female, and you can see the result here, okay? Now, what significance does this have at our level is that gender differences leads to gender disparities. Now, this data shows you female and male entry rates to universities. Here, the red is female, the blue is male. In all cases from New Zealand down to the United States, you have more females entering university than males, okay? When you look at literacy scores, girls at the age of 15 score ahead of boys in countries like Finland, New Zealand, Poland, Australia, right down to Mexico and Korea. The data is the same for our country, all right? And every time, as a senator at USM, when we sit up there watching the students come in, we see a huge number of females and fewer males, okay? Now, this is one of the reasons. All right, this disparity has to do with the neurons, it has to do with the atmosphere, it has to do with the ingestion of toxins that unfairly affects males more than females, but it also has to do with some of the major problems we're facing, but I'm not discussing that right now. The second one is this, cognitive enhancement. And this is as early as 2001, all right, 2001. There are drugs, you might want to write this down or not, okay? Such as Ritalin, that you can take to improve your performance in exams, in concentration, in paying attention, all right? It's a mild stimulus. It used to be, these drugs were used for attention deficit disorders, ADHD, all right, and hyperactive students, children, but now you find that you can take this to improve your learning, to improve your concentration, and, all right, with us. All right, because, as the BBC says, things like Ritalin, modafinil, you can't get it in Malaysia, no problem. What do? You go on the internet, you can buy it, they'll send it to you by FedEx, okay? It boosts your alertness, your academic work is done faster, it improves your concentration, and until now, all right, maybe in the long term we don't know, but up to now they say there are no side effects. So, is it wrong to take those drugs? In a meritocracy-based world, wouldn't this be wrong to take those drugs? Unfairly, because you have the funds and you have the knowledge to take these drugs, is it wrong? Okay. On the other hand, okay, we often attend classes where people tell you how to improve your brain, like this. Is it wrong to learn these things? Okay, what's wrong? There's nothing wrong with that. If there's nothing wrong to learn about improving your mind, why can't you take something that's supposed to be safe? Okay, so these are things that we have to ask. These are things we have to answer, because these are things we are going to face now. And we are facing that. Okay? Pills to boost brain power. Should we or should we not use that? So in conclusion, I would like to say that the neurosciences, all right, is one of the greatest challenges of all time. That is why people look at the neurosciences right now. That's why people want to look at the brain. Because if you can find the basis of memory, all right? If you can find out why people have Alzheimer's disease, okay? you will get the Nobel Prize. And remember, I told you that, yeah? So next time when you get the Nobel Prize, remember me, okay? Anyway, see the amount of data on the brain is increasing, right? So we have so much information about the brain, things we know about partially, but things that we do not know. So basically, what I'm trying to say is that there are so many things in the world that is so complex right now. For example, that's Newton. Before Newton came up with his theory, okay, we didn't know why the apple fell to the ground, we didn't know why there were tides, and what he did was he linked everything together with one very simple theory. And then we say, oh, so that's why, it's gravity. Simple. Simplicity from complexity, all right? Then you have Darwin. He also did so many complexities until Watson and Crick came together and made every complex thing down very simple. It's because of your DNA. All right? So right now, okay, that is our problem. We have no idea how our brains make us what we are. We have theories. We have, for example, no idea if you use acupuncture, why some people don't feel pain, some people do. We have theories, but we still don't have any idea. We have no idea about so many things, about how we think, the way we think, okay? Why are some people dyslexic and other people are not? Why is it that this method works for one person, doesn't work for the other? There are so many complex